All right, so yesterday we did 3.4, and we graphed lines that were in, someone remind me, what was the format again? Standard form. Okay, standard form, the method that we use to graph the lines is we found intercepts. What were the names of the two intercepts that we found? Yeah?
Y equals the y-intercept and x-intercept.
Yeah, the x-intercept and the y-intercept. Well, we're still going to deal with one of those intercepts today, but not both. Okay, we're going to be taking a look at using the slope and one of the intercepts. Okay? Because this equation is going to be written a little differently, we want to try to solve it in the easiest way we can. And the method I taught you yesterday is not the easiest way for these problems. Okay? So we'll talk about how to do it. Okay, so first, talk about slope. When I mention slope, like, what do you think of? What is slope? Yeah?
An angle.
Okay, like an angle. What else? Yeah.
A ramp.
Yeah, you think of like a ramp, and if I said like the ramp has, you know, a really big slope or a small slope, what would be the difference? The slope is describing the what of the ramp? Yeah?
Steepness.
The steepness, right? So that's really what slope is. Right? Describes how steep something is. So something like that versus something like that is a big difference in the steepness. And the way that we measure the steepness is we do something like this. Put a line there. Put another line right there. And then we look at how high up, like the ramp would go, versus how long it goes. Right? So this is how much distance the ramp covers. Okay? And this is how high it would get you. And if you look at those two numbers and compare them, that'll tell you the steepness. So this has a very long distance on the bottom and a pretty short distance that the ramp brings you up. Okay? So that's not a very steep slope. Now if you look at one like this, that has a big difference. Okay? This ramp doesn't have a lot of length on the bottom. Right? That's pretty short. But it brings you up very high. Right? So that one has a steeper slope. Right? So we'll talk about the names of these two things. Does anybody know they both begin with an R? Does anybody know what they're called?
Reciprocal.
No, not reciprocal. Anyone have a guess? Yeah?
Radius.
Not radius. Usually we talk about radius when we're dealing with like circles. But a good guess. Both math words that begin with R. All right, I'll show you what they're called, and maybe you'll remember. All right, so let's talk about what slope is. So slope measures the rate of change between 2 points on a line. Okay? So here's a point. Here's another point. When we want to find the slope between those 2 points, we're trying to find a rate of change. What does that mean, a rate of change? Well, it compares how far forward you go to how far up you go. That's the change we're looking at. How far forward and then how far up. So essentially it measures the steepness of a line. Okay, some places where you might actually see slope used, like in real life, when you're making a ramp, right? There are certain, I guess, like building codes that dictate how steep the ramp can be. So like, if you've got a door on a house and it's 2 feet off the ground, and somebody, you know, they can't use the stairs, so they want a ramp built, well, the ramp can only be a certain steepness. Right? So here's the ground, and then you got like your foundation here, and then your house is on top of that. Well, if you have to get up into the house, you might not be able to build a ramp like that. Okay, it might be too steep. So you may have to build the ramp longer so it's less steep for someone to get into the house. Right? But the problem with building it longer is then it takes up more room. Right? So maybe if you have a road, in front of your house, you might only have like 10 or 15 feet of yard. Maybe you don't have enough yard to build the ramp straight. And what are you going to do? You're going to make the ramp turn. So maybe it goes up a little bit, and then it turns, and it goes up a little bit, and then it turns again, and it goes up more. All right? But some way you got to fit, you got to make it work so it's not too steep. So we're going to talk about how we find the slope. Two different ways. Okay, one way we're going to find the slope is given a graph. So in that first box on your guided notes, it says given a graph in the upper left. And then we're going to fill in some words in the box below. Okay, the first word I was trying to get you to think of when you find the distance that you go up and down is rise. Okay, that's a word, begins with R. It's called the rise.
And the other one is
That's the run. Yeah. So when you find the ratio or the fraction of the rise to the run, that tells you the steepness of the ramp or the line. You also see it sometimes on roads. If you see a sign on the side of the road when you're driving, it says like 6% grade. That's a measure of how steep the road is going to be. Usually you see it when you're starting to go downhill. You'll see a sign that is about the grade. Not so much for cars, but more for like trucks. It's important that they know how steep it is, so they get in the right gear before they start heading downhill, because it's harder for them to stop. Like big trucks, tractor trailers. All right, so when you're given a graph, on the left-hand side, you've got a line. You want to write rise over run, okay, on the left-hand part of the line. And then I'm going to explain which directions are positive and negative. Okay, so where it says keep in mind. Let me see. Rise. Let me fix this before you copy the whole thing. So rise is let's make that up and down. So for rise, you're talking about up and down. Think about like if you let a balloon go, right? From helium, it rises. Rises means it goes up and down. So rise is always up and the down. If you talk about like building a set of stairs, does anybody know what that part's called right there? Well, the whole thing is a step, but like a carpenter would have a name for that part of the step. Yeah? Yeah, this is called the riser. Right? The riser is the amount you have to step up. And there's building codes for that too. You can only have so big of a step. So that's the riser. Okay, so that's the rise. Up is positive, down is negative. Okay, so that's the rise. And the run, oops, let me fix that. Well, the run is left and right. Okay? So when you're talking about run, what they call that on the stair, that's the tread. It's the amount of space you have, that's what you step on. So the tread of a stair, it goes left and right. So moving right, we're going to have that be the positive direction. And moving left, that's going to be the negative direction. Yeah.
Instead of switching the right and up, you could have just switched instead of the rise, you just change it to run, and then change the run to rise.
Yeah, I could have switched these two words, but I always want rise to be in the top for a formula that we're going to be using.
Oh, I see.
So I want rise. We're going to calculate slope. Rise always has to be in the top part of the fraction, and run always has to be in the bottom part. So up is positive, down is negative. That's for the rise. And for the run, right is positive, left is negative. Okay, so let me show you kind of like put up an example of that. Let's say I had let's do that grid. All right, let me draw a line on that grid that looks like that. And I want to find the steepness, okay, of that line. Put it like that. Well, to find the steepness of it, I have to find 2 points that are exactly on the line where the grid crosses. Kind of like we did for the dance problem and the banquet and the table problem. So try to find 2 points that are exactly on a nice grid intersection. Does anybody see a point that it looks like the line goes right through? Yeah, could you tell me what the coordinate is of it?
It's gonna be 5 going up once, -5 going up once.
So what's the coordinate?
-5 to 1.
-5, 1. Yep, looks like a good one.
2 up and 1 across, that would be negative 1.
Or you can go 3.
And that would be 2.
2, -1 and 2. Yep. Any 2 points will work. Here's another one we could have used as well. Okay, so now to measure the steepness, what we do is we count how many left and right we go, and then how many up and down we go. So let's start going from this point to this point. How many to the right do I have to go? 2, 3, 4. Okay, so that one was 4. And then how many up do I have to go?
1.
1. Okay. So what number here represents the rise? The 1 or the 4?
The 1.
The 1. Rise is the up and down. Right? Think of like a stair. Right? That part's the riser. Right? So the rise is 1. And what's the run?
4.
4. So the steepness of that line is 1/4. The bigger this number gets, the steeper the line gets. Okay. But that's the idea of how you find slope. You got to find 2 points and then count over and up. Or it could be over and down if the line was slanted the other way. Now let's say you use this point over here. Let's measure the steepness between this point and that point. How many over do you have to go here? We go 1,
4.
2, 3, 4. So it's 4 again. And then how many up? 1. So this is 4. That's 1. It's exactly the same steepness. And it should be, because it's a line. So whether you measure the steepness here, or here, or here, it doesn't matter where you measure it. The steepness is the same everywhere. For the steepness to not be the same, it would have to curve. Well, now if you try to measure the steepness, it's different at different points. And if you're standing right here, it would seem pretty flat. If you're standing here, it would be kind of uphill. And if you were standing here, it would seem like it's slightly downhill. Right? So we don't really study the steepness of curves because they change. We just study the steepness of lines. You can do curves. We don't in this class here. Is there any question on that? Right, so that's probably the easiest way to find the slope when you know, when you have a picture and you can just count. Okay, easiest way. Okay, so that's if you are given a graph. Now, another way you can do it is if you are given coordinates. Let's go back to this picture for a second. Let's label this one. What was the coordinate of that point?
Which one?
This one.
-1.
So that's -5, 1. And what about That point.
Negative 1, 2.
-1, 2.
-1, 2. So we've got the point -5, 1. What was it? -1, 2?
Yes.
Okay. So what we're going to look at now is how can you find the slope if I just tell you that? It's the same thing. Right? Slope is still going to be 1/4, but you don't have a picture this time. So you can't count and figure it out. Right? But you can still figure it out by just doing some arithmetic with these 4 numbers. And I'm going to show you how you do that. So if you are given coordinates, okay, on that first line in the table, in the box, you want to write y2 minus y1 over x2 minus x1. These 4 things that I just put boxes around would be these 4 numbers right there. So we have to take those 4 numbers and we have to fill them in those 4 spots. Do you think it matters which number you put where?
Yes.
Oh yeah. So we have to make sure we put the right numbers in the right spots. In the top, you have to put the y's. In the bottom, you have to put the x's. Okay, so what we're going to do, so we make sure we put each number in the right spot, is we're going to take our coordinates and we're going to label them. This 1 is a subscript, and what that 1 means is this is my first x coordinate, this is my first y coordinate. This is my second x, this is my second y. So if we were going to label, scroll down here. Okay, if we were going to label ours, I would say this is my first x, and then my first y. It'll be right there. The bottom one, I'm going to call that one my second x. And I'm going to call the one to the right of it, well, you tell me. What do you think the 2 would be?
First y.
I already have my first y. My first y and x those are already labeled. Yeah?
Your second y.
That's the second y value. It's the first x value in the problem, the first y value, the second x value, and the second y value. So we're going to take the coordinate that they give us, coordinates, and then label them. The first x, the first y, the second x, and the second y. And then you're going to fill those numbers into that formula. Let's try it. What's y2 in my problem?
2.
2. Minus, what's y1?
1.
1. Now, x2,
Negative 1.
-1, minus, and what's x1? -5. Now be careful in the middle there. This negative symbol comes from the formula. This negative comes from the thing in front of the 5. So what do you get in the top? What's 2 minus 1?
1.
1. And in the bottom, when you have -1 minus -5, what happens when you do minus a minus? It becomes a plus. It doesn't always turn into a plus, it just did this time because it was minus a minus. And what's -1 plus 5?
4.
4. And that's the slope of the line. What did we get for the slope when we counted on the graph? 1/4. We got the same thing. Okay. So whether you have a graph and you can count how many over and up, or you have 2 coordinates and you plug them into the formula, you're going to get the same thing. It's just a little bit more work with the formula because you have to do the arithmetic out rather than just counting. Okay, so you label your coordinates, you plug them into the formula, and then you solve it. Solve really means simplify. Do the arithmetic. So one thing about slope is we always leave it as a fraction. Okay, some of you might know what 1 divided by 4 is as a decimal. 0.25. We don't write it as 0.25. Always leave slope as a fraction. So I'm actually going to add that right here. So simplify, leave as a fraction. You can reduce the fraction. Like let's say you did the arithmetic out and you got 3 divided by 9. What does 3/9 reduce to?
1/3.
Yeah. That's fine. You can always take your slope and reduce it. But leave it as a fraction. Any questions on the formula or the counting method? And we'll practice both. Alright. Okay, so at the bottom of your first page of guided notes, we've got 4 different types of slope that I'm going to show you. Okay, these are really the 4 different ways that you can draw a line and measure its steepness. Okay, you don't have these words at the top of each graph, so you want to write down each one right across the top. So positive slope, negative slope, 0 slope, and then undefined slope. These are special cases. What kind of lines did we have yesterday that were special cases? One of them was a
vertical.
One of them was a vertical line
And horizontal.
and horizontal. So those special cases we talked about yesterday are going to each be these. Vertical and horizontal lines are special cases. Positive and negative slope, those aren't special cases. Okay, so here's an example of a positive slope. Positive slope means that it goes up as you go to the right. So think about like the direction that we read in English. As you read to the right, it means it goes up. So what do you think a negative slope would look like?
Goes down.
It goes down as you go to the...
Left.
No, this one goes down as you go to the left. That's a positive
Then
slope.
it goes to the right.
It goes down as you go to the right. Okay, as you head right, it heads down. So it falls as you go from left to right. So positive slope slants up, negative slants down. What do you think a slope of 0 would look like? Yeah?
Just horizontal.
Yeah, it would be horizontal. 0 doesn't slant up or down. Okay? That's in between a positive and a negative slope. So what's the only type of line I have left? We did it yesterday. This is going to be an undefined slope.
A non-linear slope.
What kind of line do you think is going to be undefined?
Non-linear.
No, it has to still be a line. So we're only going to talk about things that are linear. No, nothing's going to curve. Yeah?
Up and down.
Up and down. Vertical. Yes. So a vertical line is an undefined slope. So anytime I ask you what the slope of a line is, it always has to be one of those 4 things. Positive, negative, 0, or undefined? Undefined is the only slope that's not a number. Everything else is a number. But undefined, you just would write undefined. So when you're trying to find the slope, and we did an example a minute ago, a couple minutes ago. If it's a positive slope, you're going to count how many right and then how many up. This would be your run, and that's your rise. In the case of the positive slope, it goes up because the rise goes up. Now in this case, I go down, and then I go to the right. So in that case, my rise is down, and down would be a negative. Okay, when I measure slope, I always go to the right, always. The only difference is sometimes I go to the right and up, or I go right and down. But I always go right. You can count the other way. I mean, you could count it as left and up, but I prefer right and down. That's the way I do it. Okay, so any questions on the different kinds of slope? All right, let's try a couple examples. Okay, so this one says describe the slope of the line and then find the slope. Okay, when you're describing the slope, I'm looking for you to use the word positive, negative, 0, or undefined. And then if it's one of these three, tell me the actual number. Okay, all right, it's a positive slope. What is the number? 2/3, 3/5? What is the slope? Okay, so in A, okay, they give us a graph. So we do not need the y2 minus y1, x2 minus x1. We can just count. You're going to start here, and you're going to get to here. What's the first direction that we have to go, starting here, to get to the point at 2, 4? We're going to go to the...
Right.
Yeah, we're going to go to the right. And how many to the right did you go?
6.
So 1, 2, 3, 4, 5. Yeah, so we're going to go right 5. Okay, I'm just going to label that down there. And then how many up?
5.
Yeah, so it's up 5. 1, 2, 3, 4, 5. So we went right 5 and we went up 5. Okay. What's the formula that we use for slope when we're counting like this? It has the 2 words that begin with R. The rise over the run. Okay. So the first thing is the rise was 5 and we went to the right. If you go to the right, is that positive direction or negative direction? Positive. So that's a positive 5. And then we went up 5. Is that the positive direction or the negative direction? Positive. So they are both positives. So for the rise, positive 5. For the run, positive 5. So what's 5 divided by 5? 1. So that's the slope. And now they asked us to describe it. Is that a positive slope, a negative slope, 0 slope, or undefined slope?
Positive.
That's a positive slope. So I'll do it like that. It's a positive slope of, and then we said what the slope was. The only one that you can't give me a number for the slope is undefined, because it's undefined. Okay, let's look at the next one. What do you think? Yeah?
What about writing slope description? Is that positive slope?
Describe the slope. Oh, you guys, yeah, it's a little different. Slope description. So the slope description is it's positive, and the slope itself is 1. Yeah. So slope description positive, the slope equals 1. Okay. How would we describe this one?
Slope is 0.
Yeah, the description is it's a slope of 0. And that's the description. And what number is the actual slope? 0. Yeah. So this is the description. And then this time the description has the slope in it. The slope is 0. In the last one, the description did not have the slope in it. We just said the description was positive, and then we say the slope is 1. Yep.
Isn't it 0, 3?
For the slope,
Yeah.
the slope is just a single number. So the slope is not a coordinate. No, the slope is just the rise divided by the run. But in this case, we didn't even need to do that because it was horizontal. So anytime you have a horizontal line, the slope is 0. Okay, so it's kind of redundant. We're saying the same thing. Any question on that? All right, why don't you guys try 2A and 2B. So describe the slope of the line. Is it a positive slope, negative slope, 0 slope, or undefined slope? And then if it's a positive, negative, or 0 type of slope, tell me what the slope is. If it's undefined, you can't tell me what the slope is. It's just undefined.
Information.
What's that?
As in not enough information.
Well, no, there's enough information. It's just when something is vertical, the answer is undefined. That's what you call it, yeah. If I said to you something like this, find the slope of this line, that's not enough information. Because to find the slope, you need at least 2 coordinates. You can't do it with 1. So that would not be enough information. Let's take a look. All right, so in, let's see, 2A, they give us the graph, so we're just going to be able to count. First of all, is it a positive slope, negative slope, 0 slope, or undefined slope? Which one is this one? Yep.
Positive. Negative slope.
Yeah, so under the description, you're going to write negative slope. Now, if it's a positive or a negative slope, I need you to tell me more. Okay, tell me what the slope is. So what's the formula that we use to find slope when we're counting? It's the 2 words. Yep. Yep. So we're going to do the rise over the run. Okay, let's figure out the rise between the points. The rise is the up and the down. So we're going to start here. And then which direction do I have to go to get to that point?
Up.
So you're trying to get from here down to here. So we have to go 4 which way? Down. 1, 2, 3, 4. So that has a length of 4. And then what's my run? 3. 1, 2, 3. All right, and this is the direction that I went to do it. So this was 3. The first one had a length of 4, but I went down. So what kind of rise is that going to be? Yeah.
-4?
That's negative, because you went down 4. If you look back at the other page, down is negative. So the rise is down 4. And which way did I go for the run?
Right.
I went to the right, And when we go right, is that a positive or a negative?
Negative. Oh wait, no, it's positive.
So when we go to the right, that is which way?
That's all.
Positive. Okay, moving right is positive. Okay, so, and how far to the right did we go? 3. So that's my slope, negative 4/3. Okay. There's nothing I can do with that because there's no common number that goes into 4 and 3. Okay. Any question on that? Yeah. Yeah, just saying. Okay, so this one, describe the slope of the line and then find the slope. How would you describe the slope of that line? Positive, negative, 0, or undefined?
Undefined.
That's undefined. So when it's undefined, you really don't need to do the second part, find the slope, because the slope is undefined. The description is the slope. Okay, but when it's a positive slope or a negative slope, that's where you can tell me more. You can give me the actual number. Okay, any question on that one? All right, so let's try one where they're going to give us a table. Okay, so this is the same. I don't think I wrote down a spot for you guys to do this because you already have it in your guided notes. But keep in mind, that's the formula we're going to have to use in the next 2 problems. Because they're not going to give us a picture. To use this formula, how many coordinates do they have to give us? Well, they have to give us 4 numbers, but they have to give us 2 coordinates. Yep. Okay. So it says the points represented by the table lie on a line. It should say represented. What is the slope? Now, how many points did you say we need?
2.
We need 2. So this is a point. That's another point. That's another point. That's another point. How many points did they give me in that table?
4.
They gave me 4. You don't need all 4. You only need 2. Which 2? Any 2 you want. So let's pick, let's call this point 1, 2, 3, and 4. Which 2 do you want to use to find the slope?
2. 1.
1, okay, and?
2.
1 and 2. So let's write 1. It's 2 comma 1. And 2 is 3 comma 0. First thing we want to do is label them. What do we label this first number as? This is, what's the 2 going to be? X 1 is my first X. How about the 1?
Y. Y1.
It's my first Y. How about the 3?
X2.
It's my second X. And the 0?
Y2. Oh.
It's my second Y. Okay, now let's write down the formula. What goes in the top part of the formula? So it's not rise. It's the because we don't have a picture. You're gonna have 4 things right here. And I don't want to fill the numbers in yet. Just tell me the symbols.
Y2.
Y2,
And Y1.
Y1, X2, and X1. Okay, now we fill all those in. Okay, what's Y2? 0. What's Y1?
1.
1. What's X2? 3. And what's X1? 2. Okay, what's 0 minus 1?
1.
Negative 1. And what's 3 minus 2? 1. And that we can simplify. What's negative 1 divided by 1? Negative 1. Any question on that one? Okay, I'm going to skip the second table and go right to the last question, which is the easiest question, but I'm going to skip the second table. So the last way they could ask us to identify slope is in an equation. So they can give us a picture, they can give us a table, or they can give us an equation. An equation is probably the easiest way to identify the slope because all you have to do is write down the number that they give you in front of the x. That's the slope. And the number that they give you at the end is the y-intercept. It's like if I wrote something like this. What number is the slope there?
2x, 2.
2. And what number is the y-intercept?
3.
Yeah. Yeah. Let's try, see, I got A, B, and C. Let's just do A and B. Okay. Looking at A, what number is the slope? 3. You don't have to do the formula, you don't have to count anything. The slope is always the number in front of x when it's written as a formula. And what about the y-intercept? Careful. Negative 4. That's the y-intercept. Now, in this one, they didn't put a number on the end. So what do you think that means the y-intercept would be? 0. If they don't put anything, you can put plus 0. So the y-intercept is 0. And what do you think the slope is? Negative 2. Now, if I had that, what's a little weird about that one compared to like this first one?
X is first.
Yeah, what do we usually like first?
Y.
The y. We want this x on the other side.
Minus x1.
Yeah. So the first thing we would have to do in this one is we need to put that negative x on the right side. So if they give you a problem where the x and the y are on the same side, we have to fix that first. Now, what number is in front of x there?
1.
Negative 1. So here your slope is a negative 1. And what's your y-intercept? 5. Yeah. Okay, so we just had to fix it before we could do that first. Okay, we can try another one like that tomorrow. Okay, so the worksheet for tonight is 3.5 part 1. Remember, progress reports close Friday. So I'll update your homework, participation, all that stuff by the end of the week.